Well, hi, good morning. Thanks for joining me in my shop. I wasn't in here yesterday. It's been a couple of days. And I turned on the cameras here, and I haven't got a clue in my head as to what I'm going to do with this radio next. So maybe a little bit of review might help me figure out what to try next. I'm really flummoxed at this point. So I have tried signal tracing from the output into the radio. I didn't get far at all. And I've tried signal tracing from the antenna, towards the first tube. I didn't get anywhere with that either. So, it could be something I wasn't quite doing right. Maybe if I did it again it would work better. But for now, for reasons I don't understand at all, hey, a little bit more on the story of this radio. A radio that claims to be a battery operated radio with a big plug on the end of it. In the last video I showed the photograph of the battery one with the battery power supply sitting right in here. I've still found nothing about this particular radio, plug-in radio. I haven't found anything about it. But one of you who watches my videos and regularly sends me comments and stuff, very helpful stuff. Be a little rough if I said his name at this point, but so I won't do that. He's more or less told me the true story of this radio is basically that it was a battery operated chassis converted to power late in the game, and that's got to be the story with this thing. Why there's no information on it, I don't know, but I have found nothing, except I can thank another one of you for sending me some photographs of this radio. Don't know where the photographs actually came from. And in looking at the photograph, what I learned was, hey, what's going on right in here? So I hadn't really noticed these windows before. They looked like this when I got the radio. Let's see if they looked like, kind of like that. Just kind of open holes there, and I really hadn't paid any attention to it. But what really happens when you turn the band switch, this piece I just moved is supposed to swing around. I don't know why the pointer's going with it. And it may be hard to see, and I don't want to poke in there too much, but words will appear here like broadcast, shortwave, and police. Funny, they did it on both sides. I guess it's just to get the look balanced. Maybe it says broadcast, police, band, I don't know. So, but this plate doesn't move in behind here at all. But it's quite obvious how it was supposed to work. Let's see, can you see that? Okay, so looking at this, this is the band switch here. And there's a large lever here. I noticed this, but I didn't pay any attention to it. And now that I look more closely, I can see a broken off piece of, well, I would call it plastic, but it's probably some other material, plastic-like material. This must have been connected up in behind to that plate, the band naming plate. I also noticed the lighting on the radio in the photograph. It's a slightly different model. The lighting looked like there was a light bulb, light bulb, light bulb, light bulb. That's kind of odd for a battery operated radio to have that many lights, and it's kind of weird for a battery operated radio to have any lights. Actually, most farm radios have no lights on them. So in this radio, and we've seen this before, it's got the bulb here and a bulb here. There's none down below. There's a piece of cardboard behind the glass here. Cardboard's warped a little bit. And the lights are positioned so that the bulb is up against the edge of the glass here. So it's another attempt to fire light down through the glass. And the result of that is it lights up the dial really nicely, if you can make that work. It's a little tricky to get it all done so the light goes in the glass but doesn't cast down behind it. Like I mentioned, the cardboard here is kind of warped, and so I don't think we'll quite get the the effect. But there certainly isn't 4 lights in behind here, just the 2 up at the very top. So what am I going to do with this thing today? One of the last things I found out was the local oscillator was oscillating properly, or at least it was oscillating, and we can assume it was oscillating appropriately at this point. In fact, here's the my little rig for picking up the oscillator signal. So maybe what we can do is we can look at the mixer tube. The oscillator is part of the mixer tube. We can look at the output of the mixer tube, and maybe we'll see something. Maybe not. I don't know. I don't know. But you know, when you don't know what to, I've said this before, when you don't know what to do, just do something. Do something. So yeah, mixer tube. So the mixer tube is I think it's going to be this one or this one. I think it must be this one. That's the rectifier. That's the IF amplifier tube. That's the detector tube. It's got to be this one. And what was that tube? What tube is that? Where's my... Hey, where's my... Oh, you know what? I left the schematic diagram in my rec room. I was studying it last night for quite a while. Let me go grab it. Sat last night staring at this for quite a while. I have found from my experience in all kinds of things that you gotta let time go by to find stuff. So I stared at this for a long time. Didn't find very much. So let's see. If we pick the mixer tube 6A8, shown with a grid cap, that's got to be this tube here. 6A8. There's only one way to be absolutely sure here. 6A8. There's a good chance the AM radio signal is sent right to the mixer tube, bypassing this first front end tube. Is that possible? Is there any way for the antenna signal to make it past this tube? Doesn't look like it. So the only thing moving this way in the schematic beyond this tube is this line, and this line. Let's see. Follow those three wires. So this is a heater wire. So that's nothing. That's nothing. This is the plate coming up through these coils. Plate feed. And the last wire is the screen. This top wire is a screen supply wire, the way they've drawn the schematic here. So there's no way for the antenna signal to skip around the 6K7 and show up over here like it does in some radios. Some radios will reserve this front end RF tube just for shortwave. Doesn't look like that's the way here. So I could even be listening to the output of this. I listened to the input and couldn't hear anything, for crying out loud. So if we want to check out the output on the mixer tube, we have to pick off the plate. Should pick off the plate. The plate appears to be 1, 2, 3. Pin number 3. Believe it or not, I can see that. It's hooked up to the plate. So let's go and find pin number 3. Make sure I'm on the right tube here. Okay, so this is it up here. So 3 would be, find a little pointer here. So starting with the key, going clockwise, 1, 2, and 3. So this is what? What did I figure that was? 3 is the plate. 2, 3. This wire right here, coming through this coil. Plate coming through this coil. There are 5 coil cans on this radio. 5 coil cans. 1, 2, 3, 4, 5. Yeah. Okay. Well, we'll just take a look at that. We'll see what's coming out of that tube. How will we take a look? We could listen to it. Let's see. It should be coming out at. It should be coming out at the IF frequency. It should be coming out at 462. Yeah, that's not a bad idea, actually. Okay, so I'll warm up the signal tracer here. We'll eventually tune the tracer to 462. Stick it on this, on here, and we're going to hear. What are we going to hear? We're going to see what we're going to hear. Now, let me just make sure this is safe here. You know, my cat could come in here when I'm not around. Rearrange the equipment without me knowing it. Okay, so we have an antenna on the antenna's connected here. For whatever that's worth. Okay, put the tracer ground there. And now, for no good reason, even before the set is turned on, let's hear what this sounds like. You know, looking at this, right, I just noticed that this wire coming from this coil has been extended with a piece of white wire, and this wire coming from the same coil has also been extended. And you know what else I'm noticing for the first time here? There's a hole through the chassis right there, and you can tell something was once screwed down in there. Let's just take a little closer look. I'll show you this stuff. It's the first time I've noticed something in this radio. Now, so you see just behind the red wire, you see 2 holes. One is clean, but the other one obviously had something around it. You know, you see the same thing over here. Right, let me just get there, dead center of the screen. What is that? I don't know what that is. Okay, but going back to here anyway. And what tube are we looking at? We are looking straight at the rectifier tube. So this is the rectifier tube. So, you know what? That doesn't make sense what I just said. What I just said would support the idea that this was once a battery radio and then converted to this. You know, it's even possible they had a number of these radios built with battery style. And the sales department's phoning up the engineering department, the production department, saying, we can't sell these things anymore. Nobody wants a radio that takes a battery. We can't sell them. So whatever you got, we can't sell it. You got to make them so we can plug them in. Maybe that's part of the story here. Who knows? Okay, let's get back on track here, Jim. Back on track. So we're going to set this so it's going to tune right around the IF frequency of 462. Set this to RF. Set this to band A. And we'll set this to 462. It's in this area somewhere. Okay, once again, we'll listen to it. Did I even ever do it? Okay, so there's nothing there. Let's turn this right up. Come on, signal tracer. Don't act up on me now. I'm not exactly sure what just happened. Maybe it's just this switch here. Maybe it's this switch. Yeah, my signal tracer seems to have a little more life in it today than usual. I don't know. Okay, now concentration, Jim, or you're going to forget what you're doing. I already have forgotten what I'm doing. Power on. Switch on. Tubes lighting. We're in a little bit of business here. Yesterday, I spent my day yesterday, my wife and I, looking at a used vehicle to replace the one we have now. I always buy used vehicles and never buy them brand new. My current vehicle is a 2002 Envoy with 375,000 kilometers on it and about 15 repairs right on the edge. So, including rust in the frame to the point where the frame is separating in places. So we just worn that truck right out, right to nothing. Thumbs up on that. Had that truck 9 years, and goodbye to it. And we're going to buy its brother. We're going to buy a Terrain, very similar vehicle. It's 5 years old. So okay, this guy's got to be warmed up now for sure. So that's what I was doing yesterday. Totally different world from this one. What are we going to hear? First, what band are we on? We're on, okay, pretty sure we're on the AM radio band. Shouldn't make a difference. The IF should always be coming out at 462. There'll only be a good signal there if there's a signal fed into the radio to convert to 462. But there's lots of noise coming in the front end. There should be. So if that's making it, if the noise is making it through the radio, it'll be present. So I theorize. Here we go. It's virtually, there's like absolutely nothing there. Look at that. I mean, come on. Nothing whatsoever. And the crackling you're hearing is my signal tracer doing something there. I don't know what. Wow, this is one sick puppy of a radio. Let's check and see if there isn't. Maybe the B plus is not making it into some of these tubes, and I really haven't checked for it. Oh, who's here? You joined in. Now, what are you going to do here? You're just going to checking out the layout? No, this is just a little risky here. A little risk is good, though, right, kitty? Oh, you're showing the wrong end to the camera there, cat. Right, B plus, right. It's amazing I could stay focused long enough to buy a vehicle. Yeah. So we're going to set this to DC volts 500. Right, yeah, thanks cat, get in the way there. The cat will have to tell us what the reading is. So that same terminal should have high voltage on it. Yeah, come on, keep moving. Move along. Move along. Move along. Get your tail out of there. There we go. Now we can see the meter. What do we got? And you can hear it. And the voltage is 250. So while I'm doing this, might as well check the other tubes. Anyway, check all tubes to see if there's high voltage on them, except for the detector tube. So let's just do that without even studying the pin layout. We'll just go around, make sure there's at least one high voltage spot here. There we go. One of these should make that meter pop up. It hasn't moved a bit. Did I not get this? Am I already finding some trouble? Okay, so there's a high voltage terminal source. I think maybe I found this the other day. Okay, so we got the 250 there, and on the other side of this resistor looking thing, well, that's this terminal. That's nothing. Nothing at all. Wow, okay, so that's bad news. Got a capacitor here to ground. You just turn the radio off, Cat. I can't say I've ever had that happen before. Yeah, so there's something right there we got to deal with. Okay, so let's verify this a little bit. Which tube am I looking at? So that's the 6K7. That's this first 6K7. 6K7. Tube book. Excuse me, Cat. Let's get the tube book on here. 6K. HIJK. K. 6K7. Here it is. Used in the RF and IF stages of a radio. That's exactly what they're doing with it here. What happened? Something happened to your paw? And here's the pin out for it, and the plate is number 3. There's a screen number 5. No, 4. So 3 and 4 should show high voltage. Don't chew on that. 3 and 4 should show high voltage. 3 and 4 should show high voltage. Now, which is which in here? Careful, careful. What was that? Oh, you really want to get into radio repair, do you? That was funny. What do you think of that? He's trying to pull off one of his nail covers. See? He just pulled off a piece of it. Did you know that? Cats have covers over their nails that they shed. They'll find them on the floor. If you're a cat owner, you know this. I think that's what he's doing, is he's pulling one off. Or has he got something stuck in your paw? Let's see. No? No, I think he's trying to pull it off. Okay. What didn't I say something about distraction here? Distraction is bad. Here, you can be distracted. Yo! Giganto cat! He's a monster. Yeah, look, I have fun with my cats. What can I tell you? I totally lost control of what the heck I was doing. Right, we're going to sort out what's going on down here. Is that really pin number 3 and 5? Right, okay. Now don't distract me again, cat, okay? I cannot see the starter. I cannot see the pin. The tube pin. The key on the, that's what I'm looking for, is the key. Well, I can see where it isn't. It isn't anything I can see. Anywhere I can see. I got a little more, I'd like things to be a little more certain than that. Oh, for crying out loud. There's just so much junk in the way here. Resoldered wires on there. Let's go around. Let's go around. Okay, we'll watch the meter. What's this one here? go all the way around and see if maybe I just messed up here and the high voltage is somewhere else. Not there. Not there. This is a little bit of a tricky one to get at. There it is. So maybe I just made a mistake. The terminals are so bunged up in there. Or is there another red wire coming in here? It looks to me like the feed to the light bulbs is coming off of this tube terminal. They're gonna take a feed off of some heater terminal somewhere, feed it up to the lights. They picked on this tube to do it. Okay, so if there's high voltage on there, why did I count the pins wrong? I never really counted the pins, did I? So that's probably just simply identifying pin number 3. So it'd be 3, 4, 5 should have 3 and 5, 3 and 5. Okay, so we know the pin with the high voltage is 3 or 5. 3 or 5. So if it's 3, then this has to be 5. No voltage. So if it's 5, then, well, this doesn't make sense. It's a, it's really wired kind of weird, considering the tube that's in there. Look, I'm going to cut the power off of it. What are the chances this is the wrong tube in here? Wow, okay, so more evidence of this radio being monkeyed around with. Don't chew on that, okay? Don't. No. That means don't. Don't. Oh, she says, I get the game. I got the game. I know what the game is now. Now the radio's off, so she can't get a shock. Once again, I've been totally distracted. Yeah, I was going to show you. Okay, this is some really clear evidence of monkeying around in this radio, which is really going to make me very, very nervous. What are you doing in the speaker? Don't eat the speaker. Don't lick my camera, for crying out loud. Okay, at least there's one thing that's going well. No. Don't get the idea. I think she was thinking about jumping up on top of here. Here we go. Back to my... Let's get with it here. Okay, so what I want to show you, I think I can do it with this light. See that nut? Take a look at that. Take a look at that. Take a look at that. Look at that. I've got autofocus on, so there we go. Come on. Nothing worse than autofocus. Clearly that tube socket has been put in this radio from somewhere else. And we come down here, I'll look at the other way, you can see the oh, for crying out loud, I've got to fix the focus here. Give me 1 second. While I'm doing that, you can be entertained. Entertained by my assistant. Let's try this. See how this works. So look at the soldering job in there. I mean, that looks like something I did, for crying out loud. So this is all different. Oh, it's the cat again. I thought it was the camera here making that sound. She's really getting into it. Well, at a glance, the way this tube socket is wired, it appears, just at a glance, it doesn't have anything to do with a 6K7. There's too many pins shorted together. Can you see? Down in behind there's 1, 2, 3, and then you go across 4 pins. Okay, and those joined together pins, one way or another, have to be the screen of a 6K7. Hey, maybe I can find the little key here with my camera. Now that the radio's not operating, I can kind of shove it in here where I cannot. Wow, is it ever hidden? I think it's right below that the red piece of wire there. Can you please stop chewing the wires? Stop. Every time I touch the wire, she gets real interested in this spot here. Oh, here she comes. Clearly, the star of this video is my cat. Now, stop chewing there, will you? Just lose interest. Okay, I you know what I gotta do? I gotta take her away. Kitty, I gotta give you the boot at this point. Yeah, because you're just getting to say goodbye to everybody. A little bit of purring there, I thought you might enjoy. Okay, this is the door. You're going out it. Go on. That's the sound of the door closing. Okay, so I won't be distracted anymore. Oh, really? I have a certain amount of self-distraction skill. So we still don't know which pin is which down here. Let me pull the tube right out, and we might be able to see the where the shafty part is, where the key. See, there's that interference that you often hear in my shop. I have not sorted out where it comes from. You're hearing it on the signal tracer. Often it comes right through radios. Pull this guy out of here. Okay, without rotating it, key is down that way. It's exactly where I think it is. Let's see if we can see it this way. Turn this down. We don't need to hear that. Okay, now give me some light through the back of it. Okay, now I can see the shaft where the key goes quite clearly in there. And that means pin number 1. Pin number 1 is the middle of the 3 that are tied together, which then goes over. So pin number, so 1 and 8. 1, 2, and 8 are tied together. 1, 2, and 8. What would that do? 1, 2, 8, 1. There's actually 4 pins tied together in this thing. So pin 1 is empty. 2 is a heater. 8 is the cathode. So it actually makes sense for those 3 to be bound together. And then it goes across to 5. And 5 is the suppressor. So it all makes sense, actually. That makes sense. All these connected together makes sense. Okay. We should see screen voltage. Did I not get this right last time? 6K7. We should see screen voltage. I got this a little wrong. Screen voltage on 3 and 4. I'm sorry, plate level voltage on 3 and 4. 3 and 4. Okay, 3 and 4, 3 and 4, 3 and 4. So again, going 1, 2, 3. 4. So 4 is fed through this, and we know there's nothing on the other side of it. And then the voltage appears to carry on this wire. I'm not exactly sure what I'm seeing here. These things are... No, it doesn't. Doesn't seem to carry on. So what is this doing here, and what good is it? So I think I'm going to pop this capacitor off its ground connection, because I'm a little worried that I'm going to cut away components. I have no schematic. I mean, I do have these videos, of course, I can go back and look at, but I have no schematic to work from. And no schematic I can rely on. Okay, so that's kind of out of the way now. Let's go in here for a closer look. Hang on a sec. You were wondering what the editing is that I do on my videos. And sometimes I edit out little stuff like this. Okay, so have a look at that. Strange orange component. How about taking a look at it in focus? You can see how hard it is to figure out what's going on down there. Okay, so I'm going to nip this wire down here also. Oops. So I picked up the tool that was holding my camera in place. Another nipper. Now, screen circuits carry a significant current. They're like a poor man's plate, or a plate full of holes. So some electrons do get attracted onto the screen. You get a screen current, and that current has to be thought about. It's enough that you stick a resistor in, assuming this is a resistor. I've never seen a component look exactly like that. Looks a little cooked on the bottom, doesn't it? It's probably just dirt. Why don't we check this capacitor right now? It's out of the circuit and it's testable. Maybe there's a short in that thing. A short would pull down the voltage at the far end of that resistor, pull current through the resistor, heat the resistor up, potentially burn it out. That's typically what happens in a short circuit situation. What am I doing? Did I not drink enough coffee this morning? Is that what the problem is? Is there a problem? Is there a problem here? See, I'm pretty excited because the tension of having a automobile failing, which is what our truck was doing, our existing truck, and having no opportunity, you're going to get left at the side of the road at some point if you don't do something. So I've been under a little bit of emotional stress there for the last few weeks while I've faced up to the fact that I got to buy another truck. Okay, that's hooked up. Let's take a look at what we get. What do we get? Here we go. $70 microfarads, ESR, 150 ohms, ESR. Again, the ESR reading on an old capacitor of this sort, I'm not sure it's meaningful. And I mean, it's meaningful if we know how to interpret it. I think the standard way of interpreting ESR in modern circuits with little tiny capacitors is a different thing from this. You can quote me if you're foolish enough. So this isn't a short. It's not shorted. It's a different reading this time. That's that. Another slightly different reading. So, well, I can actually connect this size capacitor to my capacitor checker over here and do it right there. Let's do that. Let's nail down what's going on with this capacitor. So, capacitor checker. For a capacitor this size, I can use these long leads. They add a few picofarad, so that's not important when you're doing a capacitor, like a 0.05 here. Got it. Okay. I don't know how well this will come out on camera, but this is the eye you want to keep an eye on. Keep an eye on the eye. You can kind of see it there. It's opening up now. You can see it's a little open at the bottom. So what I'm going to do is I'm going to put 25 volts onto that battery, and then this thing's going to tell me if there's any current battery on the capacitor. It'll tell me if there's anything leaking through it. Here we go. That's suggesting super good, which sometimes means these leads aren't connected right. Let's try it again. Okay, just don't expect that old of a capacitor to read, especially these molded ones, to read super good. The one thing I didn't see, let me look it up here. There's usually a charge up moment when you operate this instrument. Has to charge the capacitor. The small capacitors charge very quickly, milliseconds. Bigger ones take a little longer. What's that here? Okay, just don't want any accidental shorts in there. Let's try it again. 25 volts. What are you doing? Exactly the same. Okay, we'll go up to 150. Exactly the same. 250. Having some doubts here. Capacitors this old just don't test that good. Okay, let's grab another old capacitor. Again, I don't know the condition of this. I haven't gotten around to testing these yet. That was a topic of another video. This capacitor came out of this radio though. I got exactly the same readings. 25. 50. No. Difference there. 250. See how the eye is more closed? Okay, so that tells me this capacitor is not that bad. It's not the best. It's not a piece of junk. Well, yeah, it probably is a piece of junk, really. But it also tells me my instrument is working properly. So let's do the test once again. As shocking as it may be, this capacitor appears to be perfectly good. Starting at 25 again, right open. Okay, so another 250. Wow, it's just so it's possible the capacitor lead inside the capacitor is separated, and in fact it's open circuit. And this looks like an open circuit test to me. I can go up much higher. I can go up 350 volts. Yeah, let's do it for excitement. Why not? Okay. Put your hands over your ears. Exactly the same thing again. So I think we're finding an open capacitor here. But okay, so we can test for its capacitance. If it doesn't show any sign of leakage, then this instrument becomes quite accurate at reading the value of the capacitance. So if there's a charge in there, which I don't think there is, it'll be gone by now. I'll go down to 0.05, 0.05. So this is the right scale. 0.05. Let me find it on here. 0.01, 0.02. There's 0.05 is right here. So when I swing this over here, this eye should open right up. Is everybody watching? Look at that. See that? So, surprising as it may be, as much as I knock molded capacitors, this capacitor I just tested, even though it looks like crap too, is actually working fine. Isn't that a stunner? Man, keep this in mind. This is a sealed tight. Molded capacitors that are really well known for failure is a Hunt's brand capacitor. Maybe they're not all so bad. There are lots of these sealed tight guys in this radio. 1, 2, 3, maybe not a lot. Okay, on to the next thing, which is what about the other component, the resistor there. Again, no schematic here. That's a resistor going to the screen. Let's see. Okay, so when we look at the schematic for this tube, 6K7, on the schematic isn't a 6K7. The schematic is for a number 15 tube. It's a 2-element tube, a two grid tube. It's got the control grid and a screen grid, but no suppressor. 6K7 comes with 3 grids, screen and suppressor. So the implication of that is that this schematic is really, I was hoping at least the front end of it would be useful, but at this point I don't think that even the front end is very useful here. For instance, I want to know the screen resistor going here, and there is no screen resistor, there is no screen for 15, so there's nothing showing here. So who knows? I'd have to do it I'd have to engineer the size of it. Another lesson learned: this schematic cannot be trusted here, 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 or here. Let's look at that resistor. Is it a resistor? It's got to be a resistor. Hey, let's try using my let's try using this instrument here. I've never tried it. This thing will also read resistance. This opens up at the very top of the scale on both. This is R, so this is 100, 500,000, all the way up to 50,000. And this is R times 100. And you can see it's just open at the top. That kind of says to me that this resistor is open circuit. But let's test it another way. And I got a whole bunch of reasons now to think that that thing, assuming it's a resistor, is open. Primarily because there's no voltage on the far side of it. But let's test it with, well, let's try this guy. Why don't we try him? So it thinks it's testing a capacitor. Really? It. Oh my gosh! I mean, okay. So if somebody put a capacitor there, then there was never any screen voltage on this tube, ever. You know, this is the source of screen voltage here, this terminal that it was going to. Could somebody have been dumb enough? Are there people out there as dumb as me? Oh my gosh. We can't live in a world with people as dumb as me floating around. Okay, wow. This is really not proceeding well. I have another old radio, a small one, but it's jammed with stuff. I worked on it a few years ago. I got a few days into it and then said to myself, you can't sort this radio out. This radio cannot be sorted out. And it's on my shelf. It's on the shelf. Actually, I went and checked it to see if the speaker in it could be used here, but it can't. But that's an example of this kind of thing happening. The radio's been altered substantially. No schematic to follow the alterations. I'm finding errors in the way it looked to me like errors in the way it's been put together. I had myself convinced it came out of the factory exactly like this. Now I'm thinking, no. You know, even if in a factory environment they made changes to this radio, it would still look like it was built in a factory. And it all does, except that square nut I showed you and the broken fitting on this particular socket suggests that this was done by an amateur. There's no way in a professional setting they would reuse a tube socket. Okay, so my new story is this radio was built or half built as a battery operated unit, but then reverted to a power unit. If it was done in a factory environment, was it ever slapped together? If it was done after the fact with a kit, it doesn't look right. It looks like there was never ever a battery type power supply on this radio. Wow, I don't know. And the real decision is, what am I going to do with this thing? I'm going to put more and more time into it. I hate to do this because I know you are watching and you are putting your time into these videos, and it's just as much fun for you as for me when these things work. But boy, I could fish around in the back of this thing for a long time. And what's it hooked up to? It's hooked up to a speaker with a diaper shoved in it, for crying out loud. I don't know. Okay, unfortunately I'm going to have to stop on this radio today. I'm going to spend the rest of the day thinking about what I'm going to do tomorrow. I think there's a really good chance this radio won't be on my bench tomorrow. I'll have something else in here. Boy, I have 100 comments to read about this radio, and in those comments, which I haven't read yet, there could be some more hints too. Maybe one of you knows a lot more about this radio than I do, and I have not availed myself of your wisdom yet. Because generally I like working in a wisdom-free zone. Okay, that's it. That's it. So sorry this hasn't gone better, but you know, and you must realize I'm completely honest when I say I have not worked on these radios except what you see on the videos. I turn them on, I don't know where I'm going with them. Occasionally it's going to be a dead end, I'm afraid. So okay, have a good day. I'm going to continue thinking about my new used vehicle. See ya.